Hello everybody, welcome to another episode of Maastricht Science Channel. Today's video will cover enthalpy, exothermic and endothermic principles. So why should we care about these topics? Let's take a look at Mike eating nuts.
Wow, how many calories were in those nuts? Firstly, let's discuss what is a calorie. A calorie is measuring energy. A more technical term is a calorie is the amount of heat required to raise the temperature of 1,000 grams of water by 1 degree Celsius. You gain weight when calorie expenditure is lower than calorie intake. A diet that contains an energy surplus will result in an accumulation of body fat, as seen on the scales. So how are we going to burn off this excess energy? We know that the heat released is equal to the energy contained within the nut. This can be determined by using a calorimetry experiment. Heat is the measure of energy being transferred to atoms and molecules because of the temperature difference of the surroundings. We define the amount of energy contained within bonds as enthalpy.
An enthalpy change can be calculated by subtracting the enthalpy of the products by the enthalpy of the reactants. For endothermic reactions, delta H is positive, and for exothermic, it's negative. This makes sense as in an endothermic reaction, heat is absorbed by the system, so the products have a higher enthalpy than the reactants. Therefore, the equation, delta H products minus reactants, will yield a positive answer. Combustion is an exothermic reaction and will have a negative delta H, as the products will have a lower enthalpy than the reactants as heat is lost by the system and gained by the surroundings. The practical can be visualized by a graph where levels of energy are being projected. During an exothermic reaction, the starting value of potential energy is higher. The energy levels are lower for the products than the reactants. All reactions have an activation energy. This barrier needs to be overcome in order for the reaction to start. Energy can be neither created nor destroyed, only transferred.
If you want to learn more about activation energy, watch our video on kinetics.
The quantity of calories determines the heat created by the combustion. Foods with high fat percentage have more calories and will therefore undergo greater combustion. 1 gram of fat contains 9 calories, compared to 1 gram of protein or carbohydrate, which both contain 4 calories. In nuts there are carbohydrates. For example, glucose. In glucose there are bonds that have bond energy, also in diatomic oxygen. When glucose or oxygen reacts, bonds are formed and broken. Chemical bonds between molecules contain energy, and when they break, energy is therefore released. This energy is absorbed by neighbouring atoms and molecules, or it expands itself into the surroundings. This process is happening in your body right now, only then we call it metabolism, and it's responsible for breaking bonds in nutrients and harvesting the chemical energy that is released. So your body has energy for fun things like running or maybe even studying.
How can we quantify this energy?
We can run an experiment to figure out how much heat is released by the nuts. It is measured using a bomb calorimeter. During this experiment, we are measuring changes in temperature. Temperature is a measure of the average heat or thermal energy of the particles in a substance. As the reaction proceeds, the energy released from the nut is transferred and heats the water, which is recorded by the thermometer. The amount of heat gained by the water is the energy released by the nut. Since we now know how much energy is needed to increase temperature of water by 10 degrees, we can figure out how much heat is released. To calculate the heat evolved by the reaction, we use the following formula. Heat evolved by the reaction equals heat absorbed by the water plus heat absorbed by the bomb. Enthalpy is the amount of energy contained in bonds, while heat is describing the transfer of energy which we can then observe as a change in temperature. Endothermic reactions decrease surrounding temperatures by taking in energy. Exothermic reactions give out energy in the form of heat. Combustion is an exothermic chemical reaction. Stored energy can be measured using a calorimeter.